Algebra 1, here are the explanations for the review questions for your quiz on Friday. These are questions based on test 21. So the first one says Marcus shot an arrow that had a path formed as a parabola. The quadratic equation is negative 16t squared plus 32x plus, sorry, that should be a t, plus 48, where h is the height in feet and t is the time in seconds. Find the time when the arrow hits the ground. Round to the nearest hundredth. So when I look at this, there's a couple ways to solve it. Yes, you could graph it, but that might not be super exact as far as where our intercepts would actually lie, because that's what we're looking for. We're looking for those x-intercepts, where one of them is going to be a positive time value that we can say that's when the arrow hits the ground. But when I look at this, I see that, well, maybe I can factor it. So I take this and I say negative 16, and I'll just use x's here, x squared plus 32x plus 48. I'm going to first take out a negative 16. And I get x squared minus 2x minus 3. And then I can actually factor that other part, the quadratic part here, and say I have x minus 3 and x plus 1. Well, if I want this to find my intercepts, I want h, our height, to be 0, our y value to be 0. And I could say, well, this could be 0 or this could be 0, making x 3 seconds or x is negative 1 seconds. Well, x is 3 seconds is the only one that makes logical sense, so I would be saying that it hit the ground at 3 seconds. So it took 3 seconds to land back on the ground. We're going to graph the function 3x squared plus 18x plus 13. So when I do this, I need to find a bunch of different things. So the first thing that I'm going to find is the axis of symmetry, which comes from negative b over 2a. So I get negative 18 over 3 times 2, or it should be the other way around, but it doesn't make any difference. And we get negative 18 over 6, which is just negative 3. So that's my x-axis. My axis of symmetry here is at negative 3. I am going to make my pen a bit smaller so that it's easier to graph here. And so here we go. X as negative 3 is my axis of symmetry, meaning my parabola is going to be symmetrical around this line. Now, the other part that I need to find here is what is my vertex? Well, the axis of symmetry gives me the x-coordinate of my vertex, so I just need to plug it in to find the y value. So y is 3 times negative 3 squared plus 18 times negative 3 plus 13. And you can go ahead and calculate all of that, expand it out, and simplify. But when we do that, and let me just do it for myself really quick, we get negative 14 as my y value, meaning I have a vertex here at negative 3, negative 14, which is going to be right about there. Okay. After that, we have our vertex. That's great. I also need my y-intercept. Well, the y-intercept always comes from my c value, which means I have a y-intercept at 0, 13. So way up here on positive values of 13, I have my y-intercept. Well, since I know my axis of symmetry, I can flip that over. Looks like it's 3 units from our axis of symmetry, so in the opposite direction, I go 3 units. And I can already start to see my parabola taking shape. The last piece that I'm going to do is plug in one other point. And since I know that my axis that's at negative 3, I'm going to plug in, let's say, negative 1 as my other value. So I plug it in and I say, if x is negative 1, I have y equals 3 times negative 1 squared plus 18 times negative 1 plus 13. And in this case, we have 3 minus 18 plus 13 gives me a negative 2. So I have another point here at negative 1, negative 2. And I'm also going to flip that across the axis. So negative 1, negative 2, and it looks like negative 5, negative 2. And so I have this skinny parabola as my graphing, as the graph of this function. All right, let's continue on here. simplify 3x over x plus 2 divided by 9 over x plus 2. Like we do with fractions, I'm going to multiply by the reciprocal, so 3x over 6x plus 12 times x plus 2 over 9. But I can factor some of these different things. So like this is 6x plus 12, I'm actually going to put that as 6 times x plus 2. Because then I can cancel out, since this is its own factor here, x plus 2 and x plus 2 are the same. I can simplify like maybe this 3 and this 6. And then all I have left is x over 18. Okay, let's continue on here. And the next one says I have 8 times the square root of 6, and I'm going to square that. Since there's only multiplication here, I really am doing 8 squared and the square root of 6 squared. So 8 squared is 64 times the square root of 6 squared, that's root 36 or just 6. And you can multiply all of that out and you get 384. All right, continuing on to the next page. Lily wants to find the width of his rectangular deck. The area is x squared minus 10x plus 24 square feet, and the length is x minus 4 feet. And so what is the width? Well, there's tons of different ways to go about this. You could definitely factor this pretty easily, and I would encourage you to do that. If though this is one that it's a bit harder to do, I would use some type of dividing polynomials method like our box method that we've seen before. So when we did this box method, remember we said if I have x minus 4 as one of the side lengths, I need to get x squared minus 10x plus 24 as the area, meaning I need to fill up these inside boxes of my rectangle with x squared minus 10x plus 24. So I start with my x squared, meaning this side length had to have an x there. So we're kind of discovering what that side length was. To continue filling in, this would have to then be 4x, since I have x times negative 4. Well, in order to get this negative 10x, this must have been a negative 6x. And I put it here because I know my side length had to have been x times something, in this case a negative 6. And then I fill in this box here. It works out perfectly to be a positive 24, which is good since that's what we wanted here. Realize that this is my other side length, and I say my other side length is x minus 6 feet. All right, complete the square. So I want to basically find a perfect square trinomial here, something that I could put in the form of x plus something squared. Well, we do that by taking this b value, dividing by 2, and squaring it. So I take 24, divide by 2, so that's 12, and then I square it. Okay, that comes from, and you can look back at that lesson, but all of those patterns that we found with perfect square trinomials, that when we do that, we get 144 here. So that we could, if we needed to, factor this to be x plus 12 squared, where you can multiply it all out and it will be the same. But this is what we're looking for, is that x squared plus 24x plus 144. All right, so after that, we have the square root of 7 over 3. Now I can actually split this up into root 7 over root 3 because we need to rationalize the denominator, meaning I need to get rid of that square root. Well, the only way to do that is by multiplying by a square root, specifically the exact one that we have, root 3 over root 3. That will rationalize the denominator, because the square root of 3 times the square root of 3 is the square root of 9, or just 3. And then on the numerator, we have root 7 times root 3, which is root 21, which can't be simplified anymore. We like that form much better than this one up here. Okay, and then we have to subtract these two ones, but unfortunately we don't have common denominators. I'm going to, though, factor these first so that I can see if I can have any factors in common. So I have 2x squared over 6 times x minus 4 minus 3x minus 4 over x minus 4 times x plus 4, since that's a difference of squares. Looks like I have an x minus 4 in common, but what I really want is my full denominator to be 6. I need that 6. I need an x minus 4, and I need an x plus 4 in it, which means I need to take this first fraction and multiply it, I'm missing an x plus 4. So I multiply by x plus 4 over x plus 4. And in the second one, I'm only missing a 6, so I multiply by 6 over 6. From this first fraction, I multiply out and I get a 2x cubed plus 8x squared. And then from the second one, I multiply out and I get, well, remember I'm subtracting an 18x and I'm subtracting a negative 24, so I'm adding 24. All right, so it looks like I can't simplify anything on the top as far as common multiples, but I do see that all of these are even numbers, so I can take out a 2. That might help with that 6 on the denominator. So I get x cubed plus 4x squared minus 9x plus 12 divided by the 6 times x minus 4 times x plus 4, which means I can simplify this 2 and this 6. So we get that numerator with 3 times x minus 4 times x plus 4 on the denominator. All right, we need a factor. And I see some greatest common factors here, and I would definitely take out a negative 5d first, so that when I take this first one, the biggest, I get a positive d squared, much easier to factor. And then I have plus 5d, and then plus 4. And if I were to multiply all that out, I would get that negative 5d cubed minus 25d squared minus 20d. And then I can look at the inside and see if I can factor that, which I can. And I'm going to factor it to be d plus 1 and d plus 4, giving me a multiplication of 4, addition of 5. And that would be my factorization. Find the zeros of the function. Well, zeros of the function are just my x-intercepts. So I'm looking at a negative 1 and a positive 3, and that's all I would have to do there. Just visualizing and finding those zeros. All right, the grades on a test were all within a range of 80 points plus or minus 15. And then write an absolute value function and solve it to show the range of grades. Okay, so when we do this, we are looking at a couple different things here. Number one, this is definitely an absolute value question because we have a plus or minus 15. Whenever I see that plus or minus 15, I know that actually goes on the outside of my absolute value because I could say this inside is 15 or it could be a negative 15, which is what I want. But the other thing is that this is an inequality to show the range of the grades. Well, within a range of 80 points means that I want it to be less than or equal to for that range. Okay, we know that it's within those 15 points. It could be 14, 13, could be 2, but it's got to be within that amount. And then in order to find what is inside of my absolute value, I say I want a difference between the 80 points that I have and what the actual test was. Some amount of test points, x, and that difference should be within 15 points. Okay? Then to solve this, I would make it into my two different inequalities. X minus 80 is less than or equal to 15, and x minus 80 is greater than or equal to negative 15, flipping both of those. And then I solve them. X is less than or equal to 95. X is greater than or equal, to 65. And so I can see, you know what, this is going to be a compound inequality. These would have a graph that would be coming together, and so I can write it as a compound inequality of 65 less than or equal to x, which is less than or equal to 90. All right, graph the inequality. Y is greater than negative 3x plus 7. So I'm going to use this graph down here. We have y is greater than negative 3x plus 7. Now to do this, I'm going to graph this just like I would any other line that is negative 3x plus 7. So y-intercept of 7 and a slope of negative 3. So down 3 over 1, down 3 over 1, down 3 over 1, and so on. But I look at this greater than sign and I say that tells me that I want a dashed line through these points. Okay, so we have a dashed line on this line, and then I have to decide, do I shade above or below? Well, I pick a point, and I typically choose 0, 0, and I plug it in. I say 0 is greater than negative 3 times 0 plus 7. That gives me 0 is greater than 7. That is not a true statement, so I don't want to include 0, 0 in my shading. I want to shade away from that, which is away from 0, 0 this way. And so I'd shade on that side. All right, find the next 4 terms in the geometric sequence. Since we already know that this is a geometric sequence, what's nice about this is that we can find the ratio between the terms. We don't have to guess, is it geometric or is it arithmetic or is it neither? We can just find the ratio by doing this one divided by this one. So 336 divided by 168 should be equivalent to 168 over 84, which should be equivalent to 84 divided by 42, and so on and so forth. Once we see this pattern, we know that we are dividing by 2 in each of these cases. So I can continue the pattern and say 42 divided by 2 is 21, divided by 2 is 10.5, divided by 2 is 5.25, and then lastly divided by 2 is 2.625. So we find that ratio, in this case 2, and we realize since we're going down, you can say we're dividing by 2 or we're multiplying by 1/2, so that if you were to put this as an equation, you would say a sub n equals my first term, 336, times my ratio, which in this case I'll put as 1/2. And you could find that in a lot of different ways. If you wanted to, you could just do 168 divided by 336 to find the multiplication ratio. And then we have my exponent of n minus 1 to finish the equation. All right, I'll just quickly go through some of these last ones here. To solve this for 0, I know that this first part has to be 0 or the second part, so we find both. So x could be 3. That would make this part 0. Or x could be -7. That would make this part 0. So those are my 2 solutions. For this next one, what I would do is cross multiply. And when I do that, I get 7x equals 6x minus 6. Remember to distribute completely. Add 6 or subtract 6x from each side, and I get x is equal to -6. That was a pretty easy one. All right. Next one we have is x squared equals 144. You could do this a lot of different ways. You could get it equal to 0 and factor. I would actually just look at this and say, I need to square root both sides. And since this is an equation, I can have 2 different solutions, plus or minus 12. Next one, get that absolute value alone by adding 11. And then we have 3 times the absolute value of x equals 21, divide by 3. And I get absolute value of x equals 7. So x must be 7 or -7. We have to have both answers. Find the midpoint of the line segment with those 2 endpoints. Well, my midpoint formula is x1 plus x2 divided by 2, so the average of the x's and the average of the y's. So when I take -2 plus 4, divide it by 2, I'll get my first coordinate point, and then 3 plus 7 divided by 2 for my y coordinate. So I get 2 divided by 2, so my midpoint is 1, 5. All right, almost to the end here. Combine, and what's nice about these is number 1, we have common denominators, which is necessary, and I have similar radicals. So I have root 2x in each one of these, which is also necessary. So all I really need to do is look at these outside numbers. 3 plus 2 minus 1, there's a little hidden 1. So 3 plus 2 minus 1 is 4 root 2x over 5. And I can't simplify any more than that. So we would just leave it as 4 times the square root of 2x divided by 5. All right, last one here. We need to solve this and graph it on a number line. Well, I would take this -4 times the absolute value of x plus 9 is greater than -1. I would subtract 9 on each side. negative 4 times the absolute value of x is greater than negative 10. Divide by a negative 4, and I have to remember, since I'm dividing by a negative, and this is an inequality, I flip the sign, and I have absolute value of x is less than a positive 5/2, or 2.5, which means I can split it to my two inequalities. Also know that it's compound joint inequality because this is a less than sign, meaning the distance, since we're talking about absolute value, the distance between our 0 and our number has to be smaller than 2.5. But I split it into x is less than 2.5 and x is greater than negative 2.5, which I can graph on a number line. It'll look like negative 2.5, 2.5, here's my 0, and I have open dots on both connected in the middle, so I'll combine my answer to negative 2.5 is less than x, which is less than 2.5. All right, I believe that I've answered each one of these questions, just checking to make sure I didn't skip something in here. And it looks like we are all complete here, so I hope this helps you review for your quiz on Friday about these questions from Test 21.